Good afternoon, energy campers. Today we are going to look at an experiment that just involves some simple supplies. I have one smaller mason jar here of warm water that would come out of your tap. You don't want to actually heat it too hot because we're going to be placing some plastic glow sticks in it. So just turn your faucet up to the hottest it'll go and fill that up with some water. And then I have another container jar here with ice water in it. And what we're going to be looking at today is how the temperature of water is going to speed up or slow down the molecule reaction inside each of these glow sticks. So I also have 2 glow sticks. So if you have those at home, go ahead and we can get them now. Let's take a minute though and maybe think about your predictions. So after I break the glow stick, I'm going to dunk it into the warm water. What do you think will happen whenever we put the glow stick into the warm water? Maybe you want to take 10 seconds and just write that down. And then also, what do you predict would happen when we break the glow stick and put it into the cold water? All right, so we're going to go ahead and break the glow stick first. So mine's pink. So you can see it start to turn like a fluorescent pink. I want to make sure we get all of the glow in here. We're going to dunk it into our hot water first. Hopefully you can see the color really nice. So this is like what it would look like if you were just outside and going to use a glow stick, kind of the color of it. Nice, bright, almost like a purple color. So we're going to place that one inside of the hot water. All right, I'm going to break the other one. And you can see that it's still a nice, very bright. If anything, it got a little more purple, maybe iridescent looking, for sure, whenever we put it inside the hot water one. I was telling the other teachers here today that I never knew why my freezer was always full of glow sticks at home. But after today's experiment, seems like my children knew about this little hack. So this is actually a life hack. Sometimes you guys look for those. But now we're going to put it into the frozen cold water. We might need to give it a minute or two till you can really make some observations about it. Hopefully you can see that at home. And I'm maybe going to put them even side by side so that you can tell a little bit more coloring wise. So on my end, it definitely, like the cold water is actually becoming streaky, the liquid inside of the glow stick. And on this end, you can definitely see that it's bright. The liquid inside is very fluid. It still has that really nice purple cast. This one's almost looking like cloudy, the cold water one. So we could assume that as the molecules inside of this glow stick are heated, that they are going to be moving faster. And whenever you put it into the cold water, the molecules in the cold water are going to slow it down and actually reduce the color enhancement of that one. So for sure, this one looks cloudy and definitely not as vibrant as this one, this warm water one. So obviously if you're outside on a hot sunny day, you're probably going to get this nice vibrant color. I'm going to pull this one out and actually put the cold one into the warm one so you can kind of watch the color change. So we're going to observe that really quickly. So we've got this kind of like a cloudy, you know, it's still pink, but it's definitely not the vibrant, bright neon color that you're looking for. We're going to put it inside of the warm one now and see if you can observe the color change kind of come back to life a little bit. So it takes a minute to kind of heat those molecules in there. But I can actually see that purple coloring. Hopefully you can see like that purple coloring coming through right here on the front. Kind of goes from that bright pink to that bright purple color. So we absolutely, if you made the prediction that you think the warm water is going to be a more vibrant color and the molecules are going to speed up, and actually it makes the liquid inside of here more fluid. You know, as we saw with this one, the liquid kind of started to almost clump, for lack of a better word. And then it kind of gets that cloudy, hazy feeling. So one of the frustrations whenever you get a glow stick of all children, it only lasts, you know, maybe a good 2 hours. So now that you have this experiment, you can actually keep your glow sticks for a very long time. I think after you would, you know, you want to put it in the freezer whenever it's still a nice, bright, vibrant color like this. But as you can see, you can put it in the freezer. It'll save the life of your glow stick, and you can pull it out, warm it up for a little bit, and you're good to go. I know my kids love to actually take the glow stick swimming at night, so they do night swims with glow sticks, which is lots of fun. But likely, you know, the water temperature is probably going to be about 86 degrees, 85 degrees. So likely our glow sticks are probably going to be wearing out, that the molecules are not going to be, you know, to the point that it's this ice cold. So that would probably be our tip for the day. Freeze your glow sticks, but more importantly, in cold water, also we could assume in cold air, your molecules are going to slow down, your air molecules or your solution molecules. In the warm temperatures, in a warmer environment, it's going to speed things up. And that's our best tip for today, guys.